Section 12.3, Standard Scores or Z-scores. The empirical rule that we learned from the previous section only applies when the value is exactly 1, 2, or 3 standard deviations away from the mean. Let's take a look at one of the examples that we did in the previous section. In this example, we have a normal distribution. Mean is 72 and standard deviation is 8. I have 80 is exactly 1 standard deviation above the mean. 64 is exactly 1 standard deviation below the mean. And from the empirical rule, we know that there are 68% of the data values fall in this range from 64 to 80. 88 is exactly 2 standard deviations above the mean. 56 is exactly 2 standard deviations below the mean. There are 95% of the data values fall in this range from 56 to 88. 96 is exactly 3 standard deviations above the mean. 48 is exactly 3 standard deviations below the mean. And there's about 99.7% of the data values will fall in this range from 48 to 96. This is what we did in the previous section. The empirical rule only applies when I have exactly 1, 2, 3 standard deviations above the mean or 1, 2, 3 standard deviations below the mean. But this is not usually the case. For example, if I have the value 62, 62 is in between 56 and 64. That is closer to 64 than 56. I know that 64 is exactly 1 standard deviation below the mean. 56 is exactly 2 standard deviations below the mean. Do I know how far 62 is away from the mean? I know that 62 falls in between 1 and 2 standard deviations below the mean. But do I know the exact distance? This is what we'll learn in this section. Trying to find the distance a data value is away from the mean. If the data value is not exactly 1, 2, or 3 standard deviations away from the mean. To do that, we need a standard score. A standard score, also called the z-score, is the number of standard deviations a data value is from the mean of the distribution. We can plot the z-scores on the special normal distribution called the standard normal distribution. The standard normal distribution is a normal distribution that always has the population mean of 0 and population standard deviation of 1. What we've learned so far is that we have a normal distribution with any mean and any standard deviation. In a standard normal distribution, the mean is always 0 and the standard deviation is always 1. So this is the mean. This is going to be 0. This is 1 standard deviation above the mean. So I take 0 plus 1. This is going to be 1. This is 2 standard deviations above the mean. I'll take 0 plus 1 plus 1. That is 2. This is 3 standard deviations above the mean. So this is 3. This is 1 standard deviation below the mean. I'll take 0 minus 1, which is negative 1. This is 2 standard deviations below the mean. That's negative 2. This is 3 standard deviations below the mean. That is -3. In a standard normal distribution, the values on the horizontal line represent the z values, while on a regular normal distribution, the values on the horizontal line are the x values. We can always convert the numbers in a regular normal distribution to a standard normal distribution. For example, in a regular normal distribution, my mean is 72. If I convert that into standard normal distribution, my mean is 0. 80 is the number that is exactly 1 standard deviation above the mean. When I convert that to the standard normal distribution, that is 1. Similar to 88, 2, 96, 3. The numbers that are below the mean in a regular normal distribution, there will be negative in a standard normal distribution. 64 is equivalent to -1 in here. 56 is equivalent to -2. And 48 is equivalent to -3. It's simple to convert the mean and the values that are exactly 1, 2, 3 standard deviations away from the mean. Because when we convert, we have 0, 1, 2, 3, and -1, -2, -3. Now, what if I want to convert this value, 62, from normal distribution to a value in a standard normal distribution? I know 62 is somewhere in here. So it's going to be -1 point something. But how do I find that out? I have a z-score formula, and that formula is used when you want to convert the data value from a normal distribution to a standard normal distribution. So 62 is from a population with mean of 72 and standard deviation of 8. If I want to convert the 62 to z in a standard normal distribution, I take 62 minus the mean divided by the standard deviation. The x value here is the value that you want to convert. Mean is the mean of your data set, and standard deviation is the standard deviation of your data set. So if I want to convert 62 to z in standard normal distribution, I'll take 62 minus 72 divided by 8. 62 minus 72 is -10. So I have z equals -10 divided by 8. And -10 divided by 8 is -1.25. So 62 is equivalent to -1.25. This is the z-score of 62. 62 is the data value in my data set. And the z-score tells me how far away 62 is from the mean. When z-score is negative, that means 62 is below the mean. -1.25 means 62 is 1.25 standard deviation below the mean. So in a standard normal distribution, -1.25 is here. Example, scores on a standardized test were normally distributed with mean of 510 and standard deviation of 95. So I have a normal distribution, mean is 510 and standard deviation is 95. Question A student scores 365 points on the test. What is his standard score? The student's score is 365 and they want to find the standard score. So they want me to find the z-score. To find the z-score, I will use the z-score formula. But let's just look at the student score before start calculating. Student score is 365. The mean is 510. 365 is smaller than 510. So this value is below the mean. My z-score will be negative. My formula is z equals x minus mean over standard deviation. X is 365, mean is 510, and standard deviation is 95. 365 minus 510 is negative 145 divided by 95. Negative 145 divided by 95, I get negative 1.52631,789. For a z-score, we normally round it to 2 decimal places. This digit is 6, so I round up to negative 1.53. The z-score is negative 1.53. That means 365 is 1.53 standard deviations below the mean. Question B. What test score corresponds to a standard score of 2.2? Now, in this case, they gave me the z-score of 2.2, and they want me to find the corresponding test score. Before I start calculating, I look at my z-score. This is positive 2.2. When the z-score is positive 2.2, that means the value is 2.2 standard deviations above the mean. So my test score will be larger than 510. I'll use the same formula. Z equals x minus mean divided by standard deviation. Z is 2.2, mean is 510, and standard deviation is 95. I want to solve for x. I need to get rid of this denominator. So I'm going to multiply both sides of this equation by 95. 95 got canceled out. I take 95 times 2.2, that is 209. From this equation, 209 equals x minus 510. I want to solve for x, so I'm going to add 5 tenths to both sides of the equation. 510 got canceled out. 209 plus 510 is 719. So the test score that is corresponding to the z-score of 2.2 is 719. Example, the weights of a certain dog breed are approximately normal distributed with mean of 62 pounds and standard deviation of 6 pounds. My data values are the weights of the dog that is normally distributed, mean is 62 pounds, and standard deviation is 6 pounds. Question A. A dog weighs 55 pounds. What is the dog's z-score? Is this dog's weight unusual for this breed? So the dog weighs 55 pounds. I want to find the z-score, and I want to know if that weight is unusual. First, let's find the z-score. This is the z-score formula. My mean is 62. Standard deviation is 6. X is the weight of the dog. In this case, that is 55. So I have 55 minus 62 over 6. 55 minus 62 is negative 7. I have negative 7 divided by 6. Negative 7 divided by 6 is negative 1.1666666. The digit 6 is repeating forever. With a z-score, we normally round it to 2 decimal places. This digit is 6, so I round up to negative 1.17. I answered the first question. The z-score is negative 1.17. The second question is this dog's weight unusual? How do we define usual and unusual data values? Let's look at the graph. I have the graph of standard normal distribution. The values on this horizontal axis represent my z-score. If the data value is more than 2 standard deviations away from the mean, the data value is unusual. So with the z-score, if the data value has the z-score of 2 or more, or negative 2 or less, that data value is unusual. So anything greater than 2 and anything less than negative 2. If a data value falls within 2 standard deviations of the mean, the data values is usual. If the data value is more than 2 standard deviations away from the mean, the data value is unusual. So when you look at the z-score, if the z-score is in between negative 2 and 2, the data value is usual. If the z-score is greater than 2 or less than negative 2, that data value is unusual. So in this case, the dog weighs 55 pounds. The corresponding z-score is negative 1.17. This number is in between negative 2 and 2, so 55 pounds is a usual value. Question B, a dog has a z-score of negative 3.2. What is the dog's weight? I'm given a z-score and I want to find the dog's weight. So I have z of negative 3.2. I want to find x. I'm using the same formula, z equals x minus mean over standard deviation. Z is negative 3.2, mean is 62, standard deviation is 6. I want to find x. So I have negative 3.2 equals x minus 62 over 6. I want to solve for this x, so I want to get rid of this denominator first. I'll need to multiply both sides of this equation by 6. The number 6 got canceled out. 6 times negative 3.2 is negative 19.2 equals x minus 62. To solve for x, I add 62 to both sides of this equation. 62 got canceled out. Negative 19.2 plus 62 is 42.8. So the dog's weight is 42.8 pounds. Is 42.8 pounds an unusual or usual data value? The corresponding z-score of 42.8 is negative 3.2. Negative 3.2 is more than 2 standard deviations away from the mean, so 42.8 is an unusual value. Example, the length of mature trout in a local lake are normally distributed with a mean of 13.2 inches and standard deviation of 1.8 inches. Question A, draw and label the distribution of the trout length. Data values are the lengths of the trout. The data is normally distributed. Mean is 13.2 and standard deviation is 1.8. So I have a bell shape. If I let x represents the length of the trout, then the value on the horizontal axis represent x. Mean is the number in the middle, right at the peak, 13.2. This number is one standard deviation above the mean. To find this, I'll take 13.2 plus 1 standard deviation. And the standard deviation is 1.8. So I take 13.2 plus 1.8, I get 15. This number is 2 standard deviations above the mean. I'll take 13.2 plus 1.8 plus 1.8. That is 16.8. This is 3 standard deviations above the mean. So I take 13.2 plus 1.8 plus 1.8 plus another 1.8. That is 18.6. This is 1 standard deviation below the mean. I'll take 13.2 minus 1.8, which is 11.4. This is 2 standard deviations below the mean. I'll take 13.2 minus 1.8 minus 1.8. That is 9.6. This is 3 standard deviations below the mean. So I take 13.2 minus 1.8 minus 1.8 minus 1.8, which is 7.8. Question B, draw and label the standard normal distribution. In this question, I want to have a standard normal distribution. Not just a normal distribution, I want a standard normal distribution. In a standard normal distribution, the values on the horizontal axis represent my z-score. In a standard normal distribution, mean is 0 and standard deviation is 1. So the mean is located here. This value is 0. Because the standard deviation is 1, so to find the values that are 1, 2, and 3 standard deviations above the mean, I'll take 0 plus 1 to get this, 0 plus 2 to get this, and 0 plus 3 to get this. To find the values that are 1, 2, 3 standard deviations below the mean, I'll take 0 minus 1 to get this, 0 minus 2 to get this, and 0 minus 3 to get this. Question C. Find the z-score corresponding to a fish that is 19 inches and draw the z-score on the graph on part B. There is a fish that is 19 inches long, and I want to find the z-score that is corresponding to 19 inches. My formula is z equals x minus mean divided by standard deviation. My x in this case is 19 because the fish is 19 inches long. Mean is 13.2 and standard deviation is 1.8. 19 minus 13.2 is 5.8 divided by 1.8. And 5.8 divided by 1.8 is 3.2222222. This digit 2 will keep repeating. For z-score, we round it to 2 decimal places. This digit is 2, so I round down to 3.22. And they want me to draw the z-score on the graph on part B. So this is my graph on part B. My z-score is 3.22, so it's somewhere out here. This fish has a length of 19 inches. Is 19 inches unusual or an unusual data value? From the previous example, we know that any values are within 2 standard deviations of the mean are usual values. Any values are more than 2 standard deviations away from the mean are unusual. To determine if the data values is unusual or not, we look at the z-score. If this z-score is greater than 2 or less than -2, then the data value is unusual. If this z-score is within 2 and -2, then the data values is usual. So in this case, this z-score is 3.22 greater than 2. 19 is unusual data value. Question D. How long is a fish that has a z-score of -0.85? I'm given a z-score and I want to find the length of the fish. I am using the same formula. My z-score is -0.85, mean is 13.2, and standard deviation is 1.8. I want to solve for x from this equation, so I'm going to multiply both sides by 1.8. So this 1.8 got canceled out. 1.8 times -0.85 is -1.53. To solve for x, I'll add 13.2s from both sides. 13.2 got canceled out. I take -1.53 plus 13.2, that is 11.67. So if a fish has a z-score of -0.85, the corresponding length is 11.67 inches.